In this video, a brief overview of NIRF ranking analysis will be covered. The NIRF, that is, the National Institutional Ranking Framework, is a framework launched by the Ministry of Human Resource Development MHRD, Government of India, in the year 2015 to evaluate the institutions with the India-centric parameter and also minimize the impact of media ranking run by non-academic agencies. The national ranking is used as one of the criteria to decide the Institutes of Eminence when there is a tough competition among institutions. This is an analysis which mainly deals with the national ranking of engineering institutions in India. The data set used for this study has been taken from Kaggle, a very popular open source datasets platform, and scrapped from the NIRF website. Source of the dataset is both primary, which is scrapped from the website, as well as secondary, which is from Kaggle, where the author has collected from the NIRF website and formatted it. The data is licensed under CC0, the Creative Commons license that allows the user to copy the data, modify and distribute it, as well as perform various tasks on it, all without asking permission, including for commercial purposes. The institutes are ranked based on the following 5 parameters. Teaching, Learning and Resources, TLR. This parameter is related to the core activities of any place of learning. They lay emphasis on measuring numbers, quality of faculty, library and lab resources, and general facilities for development of young persons. Research, Professional Practice and Collaborative Performance, RPC. The excellence in teaching and learning is closely associated with the scholarship. Therefore, faculty members are expected to make their knowledge and expertise available to benefit the society and industry. These parameters therefore attempt to measure the quantity and quality of research output as seen through international databases, IPR generation, and interface with industry with fellow professionals. Graduation Outcomes, GO. This parameter forms the ultimate test of the effectiveness of the core teaching learning activity and measures the student graduation rate and their success in finding appropriate placement in the industry and government or taking up higher studies. Outreach and Inclusivity, OI. The ranking framework lays special emphasis on representation of women and socially challenged persons in student and or faculty populations, and also on outreach activities of the institutions. Perception. The ranking methodology gives a significant importance to the perception of the institution by its stakeholders. Along with the previously mentioned parameters, other attributes present in the dataset are Institute ID, a unique ID for each institute provided by NIRF India. Name, full name of the institute. Link, a link of the full ranking report of the institute. City, city where the institute is located. State, state in which the institute is located. Score, the overall score given to the institute by NIRF based on the previously mentioned parameters. Rank, the rank obtained by the institute. Before getting into the details of the data, let us take a look at the data and the pre-processing done. First, we have data for 2016, followed by the data for 2017. Next, data for 2018, 2019, and last we have data for 2020. Here, a column link exists. This column is dropped as it does not exist in the other data frames. Finally, a column year is added to all the data frames. Then these data frames are merged. A concise summary of the dataset shows there exist no null values. Here, the city and the state are of type nominal, score is of type interval, and the rank is of type ordinal. Now we'll be looking at the anomalies that were present in the data. In ranks at certain places, values like 21A, 26A and 45A in the dataset were present. This caused non-uniformity in the data, and thus the letters were trimmed with only the digits remaining, and hence 21, 26 and 45. We removed them using a lambda function and converted them into a numeric type. As we can see, the format of the college name string in 2016 dataset did not match with the others. To avoid problems during the analysis, string formatting was done. Formatting has been done using regex. Next in the analysis is measures of central tendency. The mean for all the numeric columns in the dataset is shown below. A few observations that can be made are: firstly, the average RPC is quite low, 27.62. Thus, the quantity and quality of research work is less in many institutions. Secondly, the average graduation outcome is 60.74, which is high, but the graduation percentage of India from the census of 2011 reports only 8.15%. This is the median of the numeric columns. Now we look at the mode. It can be observed that Tamil Nadu has the maximum number of colleges in India, verifying the fact that Tamil Nadu's literacy rate is 80.33% according to the 2011 census report. Next is the identification of the distribution type of the data. This analysis is mainly focused on the graduation outcome and the overall score of the institutions. To determine whether these variables are normally distributed, techniques like histogram, box plots, QQ plots and normality tests like KS tests have been used. Graduation outcome is slightly right skewed and the p-value is less than 0.05, which rejects the null hypothesis and hence it is not normal. Overall score is also right skewed and p-value is less than 0.05, which rejects the null hypothesis and hence it is not normal. An observation can be made from the right skewedness of the two columns, that is, the graduation outcome GO and the overall score indicates that both the measures for the college are mostly greater than 50%, which should be the reason why these colleges are ranked among the top 200 and 100 ranks over the last 4 years in the country. Next is the covariance and correlation analysis. Covariance signifies the direction of linear relationship between two variables. Correlation analysis is a method of statistical evaluation used to study the strength of a relationship between two numerically measured continuous variables. The heat maps show how different parameters are correlated with the score. It also shows that the overall score is a column that shares a relation with the other columns. It can be observed that the RPC and score are the most correlated. With a correlation at 0.94, the two parameters are strongly positively correlated, and thus with an increase in RPC, there is a high chance of getting a better score. Now we will look into regression analysis. In this study, 4 regression models have been used to predict the overall score given a new set of parameter values. The models used are multiple linear regression, decision trees, K-NN regression and random forest regression. Firstly, we have multiple linear regression. The multiple linear regression model has been fit over the different parameters which affect the overall score. The model performs very well with an R2 score of 0.99 with very small error values. This seems to indicate an overfit as the model has a very high R2 score. Hence, L1 and L2 regularization models, that is lasso and bridge models, have been used to reduce the overfitting. The R2 scores of both the regularized models and the non-regularized models R2 score implies that there was no overfitting. A data frame with average overall score for the corresponding rank is created. This data frame was developed based on the 5-year merged data set that was earlier created. This plot line is later used to interpolate to find the score given a rank and vice versa. Secondly, we have decision tree regressor. This model can be used for both classification and prediction tasks. Here, an attempt to predict the overall score of a college from the attributes using a regression tree is made. Pruning is done by limiting the number of samples at the leaf node. The accuracy is determined for different values of minimum samples at the leaf node. It can be seen with min sample equal to 1, the accuracy was high, but the model ends up overfitting on the data. On increasing the value, the accuracy continues to decrease and reaches a plateau at 16. Thus, we can conclude that with min sample equal to 16, the model generalizes well. This is the code to visualize the same. Thirdly, we have KNN regression. K nearest neighbor is another supervised algorithm which takes into consideration the nearest neighbors when making predictions. Here, the choice of K has been made using the elbow method where the error rate, that is, sum of the squared error, is determined for different K values. The value that gives the least error is the optimum value. The error is least when K is equal to 4 and keeps on increasing with the increase in the value of K. Thus, K equal to 4 is the optimum value. Accuracy of the KNN regressor model in predicting the score when 4 neighbor points are considered is shown here. This is almost similar to the multiple regression model's R2 score. Fourthly, we have random forest regression. Random forest is an ensemble learning method which makes use of multiple decision trees to make predictions where each tree is different from the other. Like a decision tree, multiple hyperparameters can be manipulated in the random forest. Here, the effect of different maximum depths of the tree on the accuracy has been evaluated. As it can be seen, a very small max depth value leads to model underfitting on the data and hence a low accuracy. As the tree grows in size, it starts to generalize well on the trained set, which can be seen from the increase in the accuracy. On further increasing the depth, the tree starts to overfit and therefore the optimum choice for the maximum depth is equal to 10. This is the visualization of 4 random forest trees with max depth equal to 3. Let us now compare the 4 regression models used. For this, a test parameter was chosen. This is a score for multiple linear regression. This is a score for decision tree, for KNN and for random forest trees. The best performance was given by multiple linear regression. We can say that the rank predicted by it is close to accurate, that is, it is closest to the score obtained when calculating by hand based on the previously mentioned parameter weightage. While the accuracy of the decision tree is off by a huge amount in comparison to multiple linear regression, and the rank predicted is not accurate either. In this section, we will deal with the prediction of a rank of an institute given a vector of the parameter values using multiple linear regression model that was previously built owing to its high R2 score and statistical interpolation method. The model is used to predict the overall score from a given test parameter list. This predicted score is further used to predict the approximate rank by statistically interpolating in the DF rank scores that was created earlier. Goal-seeking analysis, often referred to as what-if analysis, is a way of finding the inputs in order to attain the desired output. Goal-seeking analysis could prove to be a very useful tool in this case study because it could help predict or estimate the approximate parameter values that an institute needs to attain so as to achieve a particular rank in the coming year. This way, an institute can get to know the areas where it is lacking and try to improve. This section deals with the estimation of these parameters from the input rank using k-means clustering technique. To begin with, the data was partitioned into 200 clusters equivalent to the 200 ranks using all attributes. Each record was then assigned to one of these clusters. The overall score obtained for the test rank was equal to 10. This was estimated from the data frame of average scores for the top 200 ranks computed from 2016 to 2020 NIRF Engineering Rankings data. The point closest to the test sample score was calculated from the cluster centers and the corresponding attributes were assigned to the test sample. Now we will look into the visualizations. Using Matplotlib, Seaborn, Plotly, GeoPandas, PandasBook, the following visualizations have been made. State-wise frequency of the colleges. Firstly, the shapefile containing the geometry of the Indian states is read. Then the data frames containing the state name and corresponding number of institutions present in the top ranks in the respective years are created. Then it is plotted using PandasBook. The interactive plot shows a geo heat map with the concentration of top Indian colleges in different states over the course of 5 years. The lighter colors indicate a higher number of institutions and vice versa. From the plot, it is quite clear that as the time passed by, there are lighter colors across the different states, which could be due to an improvement in the overall performance of institutions across the nations, or it could be due to the setting up of different institutions in various states. One sector that is rapidly growing due to the increase in the number of colleges is that of coaching institutes in India, which is primarily driven by the increase in the number of students pursuing higher education and professional courses. By 2022, it is estimated that the market size of coaching classes will reach up to USD 500 million. Region-wise scores. Region-wise, that is North, South, East and West, and year-wise, that is 2016, 2017, 2018, 2019 and 2020, grouping of parameters and scores have been plotted using Plotly. The plots show how the average scores varied for different regions of the country over the years. It can be seen that though the teaching, learning and resources have improved over the years, research and professional practice and collaborative practice, outreach and inclusivity and peer perception have decreased. This could be due to the increasing number of dropouts, decreasing number of new entrants. This could lead to a drastic decrease in the overall score of the institutions, although the graduation outcome hasn't dropped much. This could also be the reason for the drop in the employment of Indian engineers since 2016. College-wise overall scores grouping has been done and plotted using matplotlib.mlines. The slope graph of the overall scores of the top colleges from the year 2016, where the green lines indicate an improvement in the overall performance and the red lines indicate a deterioration in the performance. As it can be seen, the performance of almost all the colleges deteriorated in 2017. A possible reason for that could be the introduction of the GST by the Indian government in 2017 that resulted in a huge plunge in the economy. As time passes by, despite the continued decrease in the economy and tough COVID times, India has learned to cope with difficulties. Increase in the NIRF scores is a testament to that. Frequency of colleges per state in the year 2020. The plot shows the number of colleges in each state among the top 200 ranks in the year 2020. Tamil Nadu has the highest number of top colleges, with the rank 1 college being in the same state. However, according to the news article published in 2019, around 51% of the seats were left vacant at the end of the Tamil Nadu Engineering Counselling for allotment of colleges, and the sole problem of this was the uneven demand and supply. There are way more seats available in Tamil Nadu today than the students interested in pursuing engineering, and the same is the case with a lot of states. The AICTE has decided against allowing the opening of any new engineering college in the country for the next few years. Average score of colleges over the years. The plot shows the variation in the average parameter values over the years. It is observed that only teaching, learning and resources has improved, while the others have a drastic improvement. Although the TLR has improved, the overall score hasn't. A possible reason could be due to the decrease in number of new entrants, increasing dropouts, change in government policies and the pandemic. The MHRD in 2019 revealed a statistic that has as many as 7,248 students that have dropped out of IITs in the past few years.